Hey guys, welcome back to my channel GP Stories. So today I'll be doing ETO COC numerical problems. So I'll do all the topics that has come in the latest question papers. So by topic wise. So today I'll be doing Kirchoffs law problem. So let's start with the problem. Okay, Kirchoffs law. Okay. So first problem. Three batteries A, B, C have their negative terminals connected together. Between the positive terminal of A and B, there is a resistor 0.5 ohm, and between B and C, there is a resistor 0.3 ohm. Specification of three batteries are given below. Battery A has 105 volt internal resistance of 0.25 ohm. Battery B has 100 volt of internal resistance of 0.2 ohm, and battery C has 95 volt of internal resistance 0.25 ohm. Determine the current value in two circuits and the power dissipated by them. Let's draw the circuit. So they're saying three batteries A, B, C have the negative terminals connected together. So three batteries A, B, C. The negative terminals are connected together. This is a negative terminal, negative terminal, negative terminal. These are connected together. Okay. Battery A has voltage. A battery has voltage 105 volt. Okay. Internal resistance of 0.25 ohm. So internal resistance of 0.25 ohm. Okay. Battery B has voltage of 100 volt. Okay. Internal resistance of 0.2 ohm. Okay. Now battery C has 95 volt. Battery C has 95 volt. Internal resistance of 0.25 ohm. Okay. Now they are saying between the positive terminal A and B there is a resistor 0.5 ohm. So between A and B there is a resistor 0.5 ohm. Okay. There is a resistor 0.5 ohm. Okay. Now again they are saying between B and C there is a resistor 0.3 ohm. Okay. There is a resistor 0.3 ohm. Okay. Now what they want determine the current value in two resistor and power dissipated by them. So they want the current that is present in this loop and the current that is present in this loop along with the power dissipated. So how to find that? So we know that according to Kirchoffs law, the sum of the current entering the node is equal to sum of the current leaving the node, and the total algebraic sum of the voltages in a closed loop is equal to 0. So let's consider a loop that is A, B, C, D, E, F. Okay. And let's consider the direction of the current is in this direction, that is for I1 it is this direction and I2 is in this direction. Okay. Now first loop, that is loop A, B, C, F, A. Okay. So current is flowing from negative to positive, so that is 105 minus 0.25 I1 minus 0.5 I1 minus 0.2 I1 plus I2, because here two currents are flowing for 0.2 resistor, that is I1 as well as I2. Next, positive to negative, so it is minus 100 is equal to 0. So let's solve this equation. 105 minus 0.25 I1 minus 0.5 I1 minus 0.2 I1 minus 0.2 I1, if you remove the bracket, and minus 100 is equal to 0. Okay. Now 105 minus 100 is equal to 5. Okay. Next, minus 0.25 minus 0.5 minus 0.2 I1. So that total will be minus 0.25 minus 0.5 minus 0.2. That will be minus 0.95 I1. Okay. Minus 0.2 I2 is equal to 0. Okay. Let's take 0.95 I1 and 0.2 I2 that side. So that will be 0.95 I1 plus 0.2 I2 is equal to 5. Okay, this is the first equation. Okay, let's go to the loop, second loop, that is loop F C D E F. Okay, in this loop, so the current is flowing from this direction. Okay, so from negative to positive it is 95, from negative to positive. Okay, minus 0.25 I2 minus 0.3 I2 minus 0.2 I2 plus I1. Okay, and now it is from positive to negative, so it is minus 100 is equal to 0. Okay, let's solve this equation, that is 95 minus 0.25 I2 minus 0.3 I2 minus 0.2 I2 minus 0.2 I1 minus 100 is equal to 0. Okay, now let's solve this equation. 95 minus 100, that is minus 5. Okay, so minus 0.25 minus 0.3 minus 0.2, that will be none other than minus 0.75 I2. Okay, minus 0.2 I1 is equal to 0. Now let's take this equation that side, so that will be 0.2 I1 plus 0.75 I2 equal to minus 5. This is the second equation. Okay, so now we have both the equations, so we have to find I1, I2 current values. To find that current value, use this calculator and go to mode, press 5, that is the equation. Okay, in this equation, check the equation, a(n)x plus b(n)y is equal to cn. This is the format, that is a(n)x plus b(n)y equal to cn plus the button number 1. After that, insert the values. So first value is 0.95. Okay, next is 0.2, next is 5, next is 0.2, that is 0.2, next is 0.75 and minus 5. So now we'll get the values. Okay, so I1 we got as I1 equal to 7.0632 ampere. Okay, this is the first answer. I2 we got as I2 is equal to, what is I2? Wait one second. I2 is as minus 8.5502 ampere. So minus is the direction, so the direction has to be opposite. It's actually 8.5502 ampere. Okay, minus can be neglected, it's the direction of the current. So now we have to find the power dissipated in the resistor. So power equation is given as P is equal to I square R. Okay, so P is equal to, what is I1? I1 is 7.0632 whole square. Okay, what is R? R is 0.5. So into 0.5 is equal to, that will be 7.0632 whole square into 0.5. Okay, that is 24.9444 watt. Okay, next one is P is equal to I2. What is I2? 8.5502 whole square. What is R? R is 0.3. Okay, 0.3 is equal to, okay, that is 8.5502 square into 0.3, that is 21.9318 watt. Okay, so this is the answer. So I1 we got, I2 we got, and power dissipated in both the resistors is being found out. If you have any doubt, you can put it in the comment box. Okay, let's move to the next problem. Okay, let's solve the problem. So second problem. Okay, so here it is given the resistor of 0.525 ohms is connected to a terminal of battery that is consisting of 4 cells, each having a EMF of 1.6 volt that is joined in parallel. Okay, so there are 4 batteries. Okay, 4 batteries that is connected in parallel. Okay, draw this circuit. Okay, there are 4 batteries. Okay, that is connected in parallel. The circuit is found to be having zero point 0.8 ampere. Find the internal resistance of each cell. So it has some internal resistance. Each cell has some internal resistance. Okay, some internal resistance for each cell. Okay. This is connected in parallel. Okay, each battery is connected in parallel. Okay. Okay. So what they have given, a resistor of 0.525 ohms is connected to the terminal of the battery. So to the terminal of battery there is a resistor connected. So there is a resistor connected here. Okay. Okay. So what is this resistor? R1 is equal to 0.525 ohm. Okay. What they have given after that, 4 cells, each has a EMF. So each has a EMF of 1.46 volt, 1.46 volt, 1.46 volt, and 1.46 volt. Each cell has. So the circuit current is to be found 0.8 ohm. So the circuit has a current, that is I. I is equal to 0.8 ampere. Okay. Now what they want, find the internal resistance of each cell. So they want the internal resistance, that is R. 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 So they want the internal resistance of all each cells. Okay. So to find this, okay, first we'll find what is given, we'll write. So given is R1 is equal to 0.525 ohm. Okay. I is given as 0.8 ampere. Okay. Now EMF, that is V is equal to 1.46 volt. Okay. Now we want internal resistance. R is equal to how much? Okay. From this circuit we can see that all the internal resistance are in parallel. So for in parallel, if the resistance are connected in parallel, then what is the formula? We know the formula is that 1 by R T is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So this is for the resistance if it's connected in parallel. So 1 by RT is equal to, all the R are same, internal resistance, 1 by R plus 1 by R plus 1 by R plus 1 by R. Okay. So that is equal to 1 by RT is equal to 4 by R. That is RT is equal to R by 4. So we know, we got the total internal resistance of this cell, that is R by 4. So according to total resistance, that is total resistance. So in parallel we got the R by 4 internal resistance. So circuit will be like the total resistance. Total resistance is R1 plus RT. That is 0.525 plus R by 4. So this is the total resistance. So according to Ohm's law, okay, V is equal to I into R. What is R here? I is the total resistance, RT. So V is 1.46, sorry, I have written it as 1.46 is equal to I is 0.8 into, what is RT? RT is 0.525 plus R by 4. Okay. So we have to find this value. 1.46 is equal to 0.8 into 0.525. So 0.8 into 0.525. That will be 0.42. okay, plus 0.8 R divided by 4, okay, that will be 1.46 is equal to 0.42 plus 0.8 divided by 4, that will be 0.2 R, 0.2 R. So this will come this side, so 0.2 R is equal to 1.46 minus 0.42. So R is equal to 1.46 minus 0.42 divided by zero point 0.2. So what will be the answer? R is equal to, okay, that is 1.46 minus 0.42 divided by zero point 0.2. That will be 5.2 ohm. Okay. So internal resistance is 5.2 ohm. Okay. So first we found out the equivalent internal resistance value, that is if it is in parallel, this is a formula, so we got as R by 4. Now the total resistance R1 and internal resistance we are adding, so that will be 0.525 plus R by 4. Then by Ohm's law we will be finding this equation and the internal resistance will be 5.2. So the question asked was find the internal resistance of each cell. So internal resistance of each cell is found out and the answer is 5 by 2. Okay. So if you have any doubt, you can put it in the comment section. Thank you.